Recording is in progress. Let me share my screen. Is it visible?
Yes, it's visible for me, all right.
Okay. So let's start with today's unit number 3, which here we will cover a lot of concepts related to the loops and the decisions that are taken and how we can use them with respect to Python and what are the implications in terms of data that you will be provided with. So we'll cover the basics and then we'll go into the details with each progressing modules. But today we are going to be discussing about the basics of how we can make simple decisions using Python with the if-else conditions, or if we can use nested conditions, or the loops that can be used for iterating the data with respect to the conditions that we intend to implement. So let me just move this. Okay. So the goal for this particular submodule is to implement simple decisions using if statement. So we'll only be using if statement for now. Now the goals, the decisions are very, the decisions are basically embedded in our everyday lives. So we make decisions on a daily basis. Basically, if you have the data, let's say if you are running a business and all that, so you have to make decisions on the daily basis itself. Now the decisions can be either based on your intuition or based on the data which is provided. So in our case, we will focus on the decisions that are based on the data and how we can make rules or how we can define rules to make decisions based on the data that is provided. So making decisions allows a program to carry out a specific action depending on the data being processed. So it can be used for as a trigger point. So we define a condition and we define an action and we provide a condition that if there is a certain trigger or if there is a certain condition that is met, the action could be implemented. So that can also be done using if statements or if else statements, or in general, the decisions that are being implemented in Python. So in this case, let's consider an example of a lift where there are total of, let's say 14 or 15 floors. Now, the thing is that in this example, if we look into it, the floor 12 is really 12. But the floor 14 is actually 13. Now, in some cases, in some countries, there are some numbers missing. In that case, we need to consider the actual floor rather than the floor that is listed on the table or is displayed on the panel. So in this case, the floor 14 is actually 13 because there is no 13 number in that case. Floor 15 will become 14. So what we can do is we can implement a condition to make us know or make us aware that what is the actual floor. In this case, if we can implement an if condition that if floor is greater than 13, the actual floor would be one less than the listed one. So this condition can be implemented quite easily in terms of Python, in terms of coding in general. So we will discuss how we can implement this in Python, but just to show you an example that how we can do it and why do we need to make such conditions um, usable for our program cases. Now it can be used for just if condition, because if we have just one condition and we just want to use that condition as a triggering point, it's fine. But if we want to use true and false branches, like let's say if we define a condition and we define both of the ways where it can go. So basically, if the condition is true, then a statement is triggered. or an action is triggered. If the condition is false, then another action is triggered. So in this case, we can use if and else, both of them. Now, considering the previous example, the actual, let us say that the actual floor is actually 0. And if floor is equal to 13, actual floor is -1. Else actual floor is actual floor. So in this case, this -1 would not be here. In else, it would be actual floor equals to floor, as it is written in the left side of the um, diagram. So this, what this means is that we are defining both of the cases in a situation where the condition is true, or in a situation where condition can be false. So we can define both of the actions accordingly. If we just want to define a true branch, then there will be no else branch and the program will continue. So let us give another example. So if we are working in an environment, in a business environment, where we have to take decisions, but the decisions are taken based on the triggering condition. So, for instance, if we are working in a stock market, now in a stock market, sometimes it happens that there is a crash, or there are some ex, um, external situations that cause the stock market to crash. So what happens is that what we can do is we can provide a condition that if a certain external activity happens, or if there is a certain situation that comes up, the stock market, or the like selling and purchasing of the shares should be halted. Now, if we can do this, then there is only one condition to be run. Otherwise, everything will run as per the schedule. So we only need if condition rather than if else condition. So if there is nothing else, it's like if we only want to trigger the true branch, we can only use if condition, and all the code will run accordingly if that condition is not triggered. If the condition is triggered, then the action will be taken as per the defined rule.
Okay.
So the syntax in Python is just as a conditional check, but in this case, we need to be very careful for the indentation. So in Python, if you define if condition, the if condition would be defined. So with the if keyword, so if keyword would be there, and then there will be the condition, and then there will be column. So it make us understand that this is a compound statement. And after the colon, we need to provide some indentation. So it cannot be written in line with the if keyword. So if the indentation is provided, it will automatically understand that this is the condition that needs to be executed if the statement is true. So if the floor is greater than 13, then actual floor will be floor -1. Then there will be else. So else should be in line with the indentation with if, not the execution statement.
Mhm.
And then again, if there is a colon after else, it would have to be indentated uh, for the execution of condition, which is
Okay.
actual floor equals to floor. So this is in Python. Of course, it resembles the natural language processing or the natural language, but the thing is that indentation is one of the core part for Python programming, and it needs to be considered very carefully because many of the problems at times occur because of the improper indentation. But it's mostly automatic. So if you are using Jupyter Notebook and if you press enter with colon, it would provide some indentation automatically. And if we want to provide multiple if statements, we can provide multiple if statements. If we want to provide multiple if else statements, like adding more branches, we can provide more branches as well. So if a
Okay.
statement basically allows a program to carry out a specific action depending on the data being processed. So this is one of the sample codes that we can do. So let's say we have the valid floors that are presented to users from 1 to 15. And the selected floor is the input that is being provided by the user itself. So remember that if we just provide the input from the user, it would be considered as an string. And then we have to change it, or we have to convert it to integer, which we have learned in our previous classes. So we
Yes.
have to convert it into integer, and then that number would be considered as a number, not a string. So then again, we have to adjust the floors if required. So we will implement the condition here that if the selected floor, which is the one that is being provided as an input by the user, is greater than 13, then the actual floor would be one less than the selected floor. Otherwise, if it is less than 13, then it would be considered as an actual floor. The number would be the same as the selected floor. And the printout statement would provide us the output, and we'll know that whether our code runs properly or not based on the input that is being provided. So we will try to run this code in Python, and we'll see that what the output is.
Okay.
So I hope that after going through the slides, you will be able to answer these questions.
Okay.
Now there are also compound statements that can be used. So let's say if if there is an example of a total sales that it is greater than 100, and therefore we provide a discount to the customer. So the discount is 5% of the total sales. So in this case, discount will be total sales multiplied by 0.05. And once we get the total sales, what we can do is we can just remove the discount, and we can ask the customer to pay the remaining amount with the message that you received a discount of this. So this statement block is identified to the same level because there are some of the compound statements that are running, and they all reside with the condition. They are all linked with the condition if. So if this condition is met, then and only then this whole statement, the compound statement, will be considered or will be executed. Now, of course, we can use multiple block structures. So this is a kind of a nested conditioning. So if the total sales is greater than 100, of course, we can provide a discount of 5%, and we have already considered this for like example in the previous slide. But if the total sales are not greater than 100, which is the else condition, so what we can do is we can see how much is the difference between the total sales and the 100. So if the difference is less than 10, then what we can do is we can tell them that buy item of the day to get a 5% discount. It's not, if not, then we can tell them that you have to spend this much amount to get a 5% discount. So this is just an example to give for nested conditionings. If there is another, so if there is kind of a, you can consider it as a decision tree. So in decision trees, there are multiple structures. So if a certain statement is true, it branches off. So in this case, we can branch off the nested conditioning at whatever point we want to. And we can define multiple structures or multiple condition statements. But the common errors that are considered is that there are duplication in branches. So if there is same condition that is being repeated, it should be avoided because of the computational resources being used. So if there are same conditions that are being implemented, then it will result in more computational resources, but there will not be any benefit in providing the decision. So the decision will be provided in the same manner, but it would add computational overhead instead of reducing it. And as a programmer, we strive for reducing the computational overhead. um, because there will be less delay, and if there will be less delay, then it will be good for the customer, because at the end user they would see that how much time it takes to take a particular decision. Then again, if the same code is duplicated in each branch, then move it out of the if statement. So if there is something that needs to be run in both of the cases, then there is no need to implement it or include it in the if branch. We can move it out. And indentation. So this is the common error that is being performed, and most of the errors are actually associated with the indentation. So if the indentation is not proper, then it would result in errors.
Mm.
Now this is again one of the codes with just to make you simplify it. So if the floor is greater than 13, what we are doing is we are using actual floor equals to floor minus 1, which is the example that we have already considered. And what we are doing is we are using a print statement for this particular condition. And then for another else condition, we are also printing it
Mm.
inside the else condition. Now, if we want to print something and that particular printing operation is printing the actual floor number in both of
Mm.
the cases, so why we should use duplicate statements? Instead, what we can do is we can just print it out, um, like out of the if conditioning or out of the conditioning structure.
Mm.
So
Yeah.
it would be common. We do not have to provide multiple print statements. We can only provide one print statement. So if floor equals greater than 13, actual floor will be floor minus 1, else actual floor will be floor. So what we want to do is we want to just print the actual floor number, which can be done by moving out the print statement from the conditions. So this is how we can reduce the computational overhead as well as reduce the number of lines, which are kind of like directly, which are correlated. One more thing is that, of course, when we will consider debugging, or then it's quite obvious that the print statement is one of the best debuggers that I believe that it is, because in that case you would know that where the error occurs, because there are some semantic errors and there are some syntactic errors. So in that case, in the syntactic errors, it is very difficult to point out where the error is in the code. And print statement in that case will be the best debugger, or would be the best friend for us to identify that where the error lies. Because the code runs fine, but the output is not the desirable output that we intended to get. So that's why it is called syntactic error. So it is very useful. The print statement is very useful in debugging that. But other than, if we are using the this for a production point of view, then less number of codes would be the best way to go.
Mm.
And there are some relational operators that can be used for conditions. So previously we used greater than, but there can be greater than or equal to, which the left side, the most left side is the syntax, and the middle column is actually the symbol that is implemented through that particular syntax. So greater than or equal to can be implemented like it is shown here, and then less than or equal to, the equality should be with double equals sign. So it would check that whether both of the variables are exactly the same, and a not equal to sign is denoted by the exclamation sign and equal to. And we will cover these. We will see examples of these extra symbols that we might encounter in data that needs to be analyzed and that needs to be taken care of while applying conditioning statements. And after going this, I hope that it would be easy for you to answer these questions. And of course, if there is any feedback to improve, please let us know. So
Okay.
let us complete this module. Okay, so let me just open my Jupyter notebook to see Okay. Mhm. Yes. So in this case, let us consider that the previous example, let's say the floors are equal to 15.
Okay.
So if we will see, the floor is 15. Now, um, is there any question?
No, no, that's fine. That's fine. So no, that's great. Yeah.
Okay. So if let us implement the if condition that if the floor is greater than 13, so there is a colon, and if you will enter it, it will automatically provide the indentation which is required. And what we can do is we can use the print statement that the floor is greater than 13, just to see that whether the condition is actually met or not. Okay. And then what we can do is we can find actual floor equals to floor minus 1.
Okay.
And the next condition is else. And so the indentation is automatically provided from the ID. And here we will print the statement the floor is smaller than 30.
Mm.
And the actual floor equals to floor.
Yeah.
And let us run this condition. So we have already provided the value of the floor, which is 15. So 15 is greater than 13. So floor is greater than 13. And if we just print the value of the actual floor, it is 14, which is one less than the floor number which is provided. So the first condition is met, and that was the intended output that we wanted to get.
Mm.
And one more thing here is that the previous example where I said that the print command can be moved out, um, because we want a common output. So in this case, that doesn't holds true, because here what we are doing is we are our print statement is catered to a specific condition. It is not common. It is not just printing out the number of the actual floor, but it is printing out the outcome that whether the floor is greater than or smaller than the 13th floor. So in this case, we cannot move out unless and until we find a common ground to print out. Okay, so
Okay.
so again, if we want to have the input from the user, what we can do is we can use the input command, and we can ask the user to enter a number. And if we do so, it will ask that what number is being provided. So let us say that we provide the number 41. And in this case, we can see what the number is, but here you will see that the number is in string format. As I
Yeah.
previously suggested, that if anybody inputs a number, it would be in the string format. So what we have to do is we have to convert it to integer value. And if you will see, it's a number at this point of time. We can print out the type, and it would say that this is the integer. So we can implement a simple let me give you an example of. So previously we discussed that if there is something that needs to be executed, that needs to be triggered, we only need one if condition. If we want to define both of the branches, then we can use if and else. Okay,
Okay.
so let us say that Johnny. Okay, so let us just define if number is greater than or equal to 20, then print the condition is met, therefore action will be triggered. And we would say number is number -1.
Okay.
Otherwise, if the condition is not met, then the number would be number +1. Or just remove this. So let's say that we just want to work our condition. If the condition works, then it's fine. Otherwise, we would not be running this. So the condition is met, therefore action will be triggered because the input number is kind of like greater than 20. Now let us just rerun this input number and let us say that it's 19 instead of 41.
Mhm.
Okay. And we would run this again, so it's number 19. We convert it to the integer and see, okay, number is 19, the type is integer. And we would see if the condition runs. So the condition doesn't run. And then number here is still 19. So there is no number -1. So in this case, if we just want to implement a single condition uh, to be executed, then we can only use if statement. If not, then we have to define both of the branches with the if else. So just let me define it. So if number is greater than equal to 20, it would print the condition is met. Therefore, the condition is met for greater than 20. And then the number will be number -1.
Mhm.
Else print the condition is not satisfied and the number would be number +1. In this case, we have defined both of the conditions, and you will see that the second condition has been implemented, which is the condition is not satisfied, and the number would be now 20, which is number +1. So this is how you define both of the conditions. And we can use the same one with the if. Okay, I think we have already implemented if else. Yeah. So that is the example of the flow that we use to implement. We can use multiple examples of that. For instance, let's say we have um, an item quantity of, let's get the input from the user. Please enter the quantity of purchased items and the price, let's say, is 100. Okay. So purchase items, let's say 20. We have quantity of purchased items. So if item quantity is greater than 10, discount equals to price multiplied by 0.05. Okay, so we provide a 5% discount here, and the total price would be price
Okay.
So we'll see that what is the discount here. So discount is 5
Right.
euros. And we can see that what is the total price here, and the total price will be 1900. So if we have purchased 20 uh, like 20 items, and each item is 100 euros, so it would be 2000, sorry. So 2000 euros will be the bill, and because there is a 5% discount, so we end up with 1900 euros as the total price. So this is how you implement, and I think it's the best way to understand that how we can use this for use the conditioning for different data problems, the data set problems that we have. Let's assume that you have a data from Walmart, and you want to see you want to apply you want to add another column for to see that how much discount has been paid off. So you can use this particular conditioning to see if there is the discount for a particular user, and at the end you can cumulatively sum that how much discount has been provided to the customers per day. So this is one of the basic examples that how we can use this conditioning to real world problem. So is it clear? If
Yes,
yes,
yes, Sundar, that's fine. That's fine. Yeah.
okay, so let us move to another module. So what we have
Okay.
discussed so far is making very simple decisions. Okay,
Right.
but sometimes there are complex decisions to be made, and most of the times it's the later case that we have to deal with complex decisions when we are when we are considering real world problems.
Mm.
And for that, of course, the conditioning would be more complex. Rather than making simple statements, we have to make more complex decisions. We have to maybe use nesting conditions for maybe driving kind of a tree like structure. So in
Mm.
this case, let's say if there is a bartender, and he is asked to provide juice. If
Mm.
it is providing a juice or a coffee, it can provide easily. It doesn't need to have a condition. So if
Mm.
anybody orders a juice or a coffee, yes, it's delivered. But if anybody orders a wine, then it needs to be checked that whether the person or who is ordering the wine is above 21 years or below 21 years.
Mm.
If above 21 years, we need to check the ID. If the ID is checked, then of course the person is above 21 years, the wine is delivered. If not, then we would have to cancel the order. So in this case, there are two conditions at first level, and then there are again two conditions at the next level. And we can define multiple conditions at the same time. So it depends on the application, it depends on the example that we are considering. So in this case we have two levels of hierarchy, which is the first level and then the second level. And basically, if you will if you will go into the details of decision tree, the decision tree is basically implemented in the same way. But of course, there are some more intricacies involved. But this is how the decision tree is exhibited. That
Mm.
these are the conditions that we need to check, and this is how we take the decisions. So
Okay.
in this case, this is the flow chart. We will see that what is the what we say is importance of the flow chart in this case. So it's like if somebody asks for order, um, it checks the condition. If the condition is true, we can check the ID.
Yeah.
If the ID is exhibiting that the person is greater than equal to 21 years, we can serve wine. Otherwise, we do not serve wine. And if the order doesn't include wine, it kind of serves non-alcoholic drink.
Mm. Okay.
So this is one of the example code for this. So if the user can be served a glass of wine or not, if let's say the age limit is 21 and we want to take the order, so we want to make the input that one for wine or two for water, or let's say coffee or any orange juice. So it's up to us that what we define this problem as. But the main thing is that we implement the if else condition. So if the order is not equal to 1, here is your juice. This is the path 1. Else age equals to, like, the age is being input by the user, and if the age is less than age limit, then of course we have to print, sorry, you are not old enough to get a wine, else we can serve the wine. So this is some of the nested structure that can be used in Python for implementing such situations. We'll see how it works when we discuss the coding. But this is just the syntax that can be used for such situations. Now, of course, there can be multiple paths that can be implemented. So in that previous example, we considered that there was a single path at one point. Like for this, there is a single path. But of course, we can use the nested condition in this place as well. How we can use this? So let's say if we have a condition that if the person is single or married. So if the person is single, we have to calculate the tax accordingly. So we have to ask that what is your annual salary? If your annual salary is like less than or equal to 32,000, then there will be a 10% tax bracket. Otherwise, there will be a 25% tax bracket. And if the person is married, then again condition could be checked that if the salary is less than or equal to 64,000, if the condition is met, then there would be 10% bracket, otherwise there would be 25% bracket. And of course we can more fine grain these conditions as well. Like let's say if we want to see that whether there is less than or equal to 32,000, then we can add one more condition that if it is less than or equal to 30,000 or 28,000, then there will be no tax, or if it is in this condition, there will be this much tax. So it can be more fine grained, but just to give you an example that more paths can be possible in the nested conditions. So this is the example of four branches, which we have studied in the previous slide. Said if you are single, earning at most 32,000, the tax is 10% of the amount over. So because it is less than 32,000, so there will be no amount over. If it is over 32,000, then the tax will be 25% and of the amount over 32,000. And if the person is married and the salary is less than or equal to 64,000, the same condition for over 64,000 and less than 64,000. So this is the condition that is actually implemented previously. So we can implement this in Python code. What we can do is we can consider that whether the marital status is equal to single, as refers to the single. If it is single, then we have to consider the rate one single limit, and the tax would be calculated like this. Else the tax would be calculated like this. But if the income is like if the marital status is married, and then we have to consider the second rate, which is 64,000. So if the income is less than this, then tax would be calculated like this, and the tax would be calculated like this. So there are total of four parts that are actually implemented here.
Yeah.
And we can finally calculate the total tax here.
Yeah.
So I hope that it would be easy for you to answer this question now. And we can define multiple alternatives as well. So in this case, in the previous example, what we are doing is we are considering that if there is one condition, and from that one condition we are branching off the other conditions. Now what we can do is we can define multiple alternatives at this first instance as well. So let me give you one more example. So based on this, there are two paths, and from those two paths we are nesting more conditions. But what we can do is we can add more paths as well. Like it is not limited to have only two paths at the first level. We can add as many paths as we like in the first level as well. And that's what we are defining here in the multiple alternatives. So we want to implement simple decisions using if and else if statements. So instead of using else, we are using else if. Now, this is one of the examples that we want to implement. Let's say we have a Richter scale example, and we want to say that if the value is 8, then the effect would be that most structures will fall. And the branch details is that the Richter scale is 8 or greater. If it is between 7 to 7.99, then the effect would be many buildings destroyed. If the value is between 6 and 6.99, then many buildings damaged. Maybe some can collapse. If the value is uh, between 4.5 and 5.99, the damage to poorly constructed buildings. And if it is less than 4.5, then maybe there is no damage. So it depends that how many cases that we want to define. In most of the programming languages, switch statement can also be used. Of course, we can talk about switch statements later on, but at this point, we want to keep it simple. So we will only be using else if and else if statements. So in this case, the multiple alternatives tells you that what if you have more than two branches, which I already said that we can define more than two branches at the first level. And what we want to do is we want to count the branches for the following earthquake effect examples, which is 8 or greater, 7 to 7.99, 6 to 6.99, and 4 to 4.5 to 5.99. So this is one of the tables that we want to implement, and we can use multiple if statements to test the general conditions after the more specific conditions. Now, of course, you can use multiple if statements as well, but you have to define each condition separately, or you can use one structure to define all of the conditions. So it all depends on the programmer that what he chooses to use.
Mhm.
So in this case, if we use multiple branching, we have the conditions and all the conditions are linked. If you use only if statement, then all of the conditions will be disjointed. Of course, you can logically link it, but um, in terms of programming logic, it won't be linked. That is the only difference. So if the
Mhm.
condition is greater than or equal to 8.0, most structures will fall, will be printed. Otherwise, if it is 7.0, then this statement will be printed, that is many the buildings destroyed. Then if it checks that if it is greater than or equal to 6.0 but less than 7.0, then many buildings considerably damaged, some collapse will be printed. And if the statement is false, but if at the Richter scale shows that the value is less than 6 but greater than or equal to 4.5, then the damage to poorly constructed buildings will be printed. Otherwise, this statement will be printed, which is here. Okay. So else if statement is short for else if. As soon as one of the test conditions succeeds, the statement block is executed. Okay. If none of the test conditions succeed, the final else clause is executed. So it can be multi-way branching. So in this case, what we want to do is previously, sorry. Uh, there. Let me get back to the slides. You have unit 3, making complex decisions.
Yeah.
So previously, what we did is we just defined that these are the intuitive conditions that we want to implement. But now let's see that how the syntax works. So in terms of syntax, we have to define it like this. So if this condition is met, then we have to print this. Else if we have to define the condition and we have to print it. So in all of this, else if needs a particular condition statement as we define in if condition. In else conditions, we do not define any statement. We just leave it to it that if the if condition is not met, then it would always be implicitly be following else condition, which is the general case. In else if, we need to provide the conditions as we do in the if statement. So in this case, if we consider that what is wrong with the statement, I already told you that there would be, you can define multiple ifs for this case. So you can define multiple ifs and you can see that we have defined if the Richter scale is greater than or equal to 8.0, this condition will, if this condition meets, we can print this. 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 Now the problem is that if none of the conditions are met, then what we can do?
Well,
So
then
in if
we print we should be printing the statement little or no damage.
yeah, but if you use the print statement outside of the if conditions, it would be printed no matter what.
Okay.
So that is the problem in this case.
You need an else if, is it?
Yeah, if we need else statement, and if we provide an else statement, then why should we add more structures with only if statements? We can just provide a structure with else if to make it logically connected. In this case, these are not logically connected. In terms of programming, in terms of logics, of course, they are connected, but we are defining separate if statements for each case. Of course, we can define a separate case here, which is if Richter is less than 4.5, then it would print something. That can be done. But again, it's not recommended because when a programmer or when any other programmer would read your code, he will assume by explicitly, he will assume or he or she will assume that this is all disjoint. They are all not connected. That's why if statements are defined. Or let's say if we want to define more cases, but here if a statement is defined that is general for less than 4.5. So in that case, there will be a problem with the developer that is taking over your job. So what we want to do is we want to make it readable and we want to make our code more optimized. And this is not an optimized way to do the things. But of course we can do it. It's like it is uh, it's allowed. It's allowed in the rules, but it should be avoided if possible.
Yeah.
That's how we can define it. So we can work on it. So there is no need of the Python file. So we can work on this example and we can see what the result is. And this, I think that you will be able to answer this question now. And if there is any feedback, please let us know. So let us go back to the examples that we have learned and see how we can implement those. So first example was of the wine. Okay, so let us consider this. Hmm. Okay. So let us consider this example. So if we have, let's say, age limit that is defined as 21, okay, we want to print that what would you like. Order is equal to, we take the input from the user, that one for wine or two for orange juice in this case. So if order is not equal to 1, we can just print, here is your orange juice,
Mhm.
and the else condition is age equals to int, and we can check the ID. So this is the condition where we are checking the ID of the user. How old are you? And if the age is greater than the age limit, print, sorry, you are not old enough to have wine, and else we need to consider the indentation as well.
Mhm.
You have to print, here is your order, and run it. So let's say we order for 2. So here is your orange juice. Let us run this again. We use 1, and how old are you? Let's say 18. Sorry, you are not old enough to have wine.
Okay.
So this is how the conditions are working. Now let me ask you this, that what if we need to reverse this case? Now, of course, we will input the age of that's the same case. But if we want to implement like this, if the age is greater than or equal to age limit, then what we do? So these statements would get switched, the print statements. So in this case, what I can do is I can write, here is your order, because if this condition is met,
Yeah.
okay, then here is your order, else this one.
Yeah.
Okay, so let us see if we can get the same result. So this is one for wine and the age is 18. We get the same result. So it depends on how you implement the condition. It can be implemented both ways. And there is no right or wrong. It depends on that how you want to implement it and what is the desired result that you want to get.
Yeah.
Okay. So this is one of the examples. Let's say we use another example here, which is of the text that we have studied. So let's say we want to have input over that, are you single? Yes or no. And if single is equal to yes, so it checks the condition. And we will see that how we compare the string formats, because this is very important that when you compare the integer value, you can just write the values. But if you want to compare the string values, you have to use these quotation marks to compare. It would consider that both of the values that are being compared are string values. Okay.
Yeah.
And income is equal to integer, and we are getting the input value of what is your income. If income is less than 32,000, so here you would see that I'm not using quotation marks, so this is just the comparison of integer values. And your tax is percent, else we can print that your tax is at 25%. And we can just remove this else because this is 4-path branch. So we can use income if the single is if the condition is not met with the single, we can have another input. But let me convert it to the integer first. Okay, so this is what is your income again. We would like to ask the question: if income is less than 64,000, we can print that your tax is at 10%, and we need to write else here. Is 25%. If we run this code, it will ask, are you single or not? Let us say that no. So what is your income? Let me say 55,000. So it would say your tax is at 10%, which is the desirable outcome. Let me run it again and say that yes, single, what is your income? Let's say we provide the same output, and it would say that your tax is at 25%. So this is how multiple branches are run. Of course, you can use multiple if statements, but it would um, make your code lengthier, because in this case, if the single is yes, then you can define that you can again define the income, and then again you have to define if the condition is you have to define compound statements within if, like if it's single and the income is less than 32,000, then this, if the income is this and greater than 32,000, then this, if the status is not single and greater than 30. So you need to define more compound statement, which gets more complex. We will learn about compound statements within the if conditioning, but as of now, to make it more simpler, we will use this, like if else conditioning, and the part kind of like dividing it into a tree like structure. Okay. Now for the multiple, let us say that the Richter scale, and let us get the output that the Richter scale output is if the Richter underscore scale is greater than or equal to 8.0, print most. So let me see what was the condition here. Okay. Yeah, so this one, most structures will fall.
Mm.
And we can use else if Richter underscore a scale is um, greater
So,
than. So if the Richter scale is greater than or equal to
7.0.
yeah, so let me define two statements here, because the thing is that if I just define Richter scale is greater than or equal to
Right.
let's say 7.0.
Yeah.
So what it does is it is not only catering to the first statement, but the second statement considers both of the statements true
Mm.
by default. So of course you can use it. It will run as you want. I will explain the effect later. So let's just use this and let us see that what was the condition. Many buildings destroyed.
Yeah.
Buildings destroyed. Let me underscore greater than equal to
Six.
6.4. And we can, sorry, many buildings damaged, some call it. Mm, mm, it is 5.0. We can print the statement damage to poorly constructed building. And then we can define else for the other condition, which is um, no destruction of buildings. And we can run this code. So let's say the vector scale output is 8. Most structures will fall. Let us run again. Let's say it's 7.5. Now, why is this error? Because it's not the integer value. Okay, so and
Oh,
we
yeah.
have considered that this is then integer value because we have defined integer here. So what we can do is we can define it here
That's float.
7. Oh, sorry, 7 instead, and it would work. Okay, so in this case, if you want to consider the floating point numbers, you have to convert it to double value, and then it would work.
So if you
So
wanted to, if you want to convert it under to double value, you have to go back and basically instead of int, you've got to put in float.
no, double. So you can use
Oh,
double keyword.
okay.
Maybe let us see if it works. Okay. Oh, okay. Double is not defined. Just float. Yeah, float. And if we consider 7.5, okay, it works.
Yeah.
Okay. And if we consider 6.5, and okay, it's working fine. If we define 5.5, okay, it is still working fine. Let's say we define 4.5, and yeah. Now, the problem which I was considering, okay,
Mm-hmm.
let us say that I just um, move this condition, just use this. It should work in the same way, right? I mean,
Um,
if we use 8, it works. Does this work properly?
and does it? When you put in 8, it was. It should say the buildings, many buildings destroyed.
Yeah.
No, most structures.
So we are defining the 7. Okay, let me just do this so it's more appropriate. So this is for the 7, and this is like most of the building structures would fall.
Okay.
Let's run this again. 8.0.
Yeah.
So what's happening here? I have provided 8.0, so it should work as Richter scale is greater than 8.0. It should print out most of the building structures would fall. But instead, it prints out that what, because it follows a chronological order.
All right. Yeah.
So previously we first defined 8.0, and then we defined 7.0. So if there is 8.0 first, it would check that, okay, this condition is met. Okay, it's running. And if there is 7.0 at the second condition, it would check if it is not 8.0, and if it is less than 8.0, then I should execute the statement which is written with 7.0. So that was working fine because we have defined it in the chronological order. But if we do not define it in the chronological order,
Mm.
then what happens is that it will see that what condition is met first.
Yeah.
So we have defined that if Richter scale is greater than or equal to 7.0, 8.0 is greater than or equal to 7.0. So if the first condition is met, it will just print out this.
Yeah.
Okay, so
Yes, you're correct. I see what you're saying. It assumes that the logic of the programming assumes that the input will be put
yeah,
into in descending order.
so what we can do here is we will learn it in the later modules, like sub modules. I'll go through them. So what we can do is we can just use something like this, which is Richter scale is less than 8.0.
Okay.
So what we have done is we have defined two conditions, that
It's
if this
confirmed. Yeah.
condition is met and this condition is also met.
Mm.
So I hope that it would work now. Yeah, so it works fine,
Yeah.
even if the chronological order is not followed. So this is one of the things. Of course, I can do it with the if statements, but because we are limited by time and we have to cover a lot, so let's go back to our lectures. Okay. Um, and as I said that we can use flowcharts, and
Mm.
flowcharts are very important. So here in this case, we can use flowcharts to define our algorithms. Okay. So in this case, let us take the same example and we are defining the flowchart. So this box, this rhombus box, or this box is defining the condition. So we define the condition here in this case. So this is important that we follow this convention. to use the symbolic boxes that define a specific characteristic
Okay.
of the loop, of the conditioning use case. So if the condition is met, then we have to go either way, as the structure is suggesting. Uh, okay, and let me give another example of this. Okay, I think there is no example. Okay, so basically, let me go back to the slides here. I think we made some of the, in the complex decision, we have others. Yeah, in this case, yeah. So basically, in this flow chart, this is the condition where it is defined. Okay, this is the rhombus, or this is the symbolic box which defines the condition. And again, it is used here. So we have to define the condition in this symbolic box. So if you are providing the flow chart, I know what to do. I know that we have to ask for the order. And this is not the condition. This is just asking for the order. And this is just the value which is defined. The condition is met here, wine and question mark. So if the order asks for a wine, and if the condition is true, then there is a value, and if the condition is false, then there is a value. Okay, and if the condition is true, then again there is a condition that if the age is greater than or equal to 21. So we have to implement the condition here. If it is true, then of course there is a value, or there is an action. If it is false, then of course there is an action. So these boxes define values or actions. These boxes define the conditions, and this box defines that this is the termination of the code, or termination of the um, what we say is our program. Okay. And okay, let me just go back to this. And there are some things in this lecture that we need to consider. So we have already gone through the flow charts. We have gone through this block structures. We know about the common errors. Again, for the comparing, as I suggested, that we need to compare the integers, the floating point numbers, and strings. Okay, and for this we can use operations like relation operations like this. But if you want to consider, let's say the maybe equality sign, or maybe with the assignment sign, it's different. So here it is just the assignment. Here it is testing the equality, that whether something is true or not. And for the strings, we need to use the quotation marks to check whether they are the same or not. So if we use name1 is equal to name2, then we are comparing both of the strings. Okay, and for comparing the strings, you need to understand that this is a case sensitive language. So even if there is one letter that is in the uppercase, it would result in false. Okay, so in this case, both of the names have same spacing, same spelling, and same cases. So it's true. But if there is something which is like E is capitalized, so it will return false. So this is one of the things that needs to be considered while comparing the strings. And in this case, if 3 is less than or equal to 4, it will be true, because 3 is less than 4 and we have used the correct notation. But if we will use like this, the equal to sign before the less than sign, then it would generate an error. Okay. And again, 3 is greater than 4, so it will generate false, which is the Boolean value. 4 is less than 4, it will generate false. 4 is less than or equal to 4 will generate true. This will generate true because 5 minus 2 is equal to 3. 3 is not equal to 5 minus 1, which also yields the true value, the Boolean value. Now, if you will do this 6 divided by 2, which is equal to 3, it will generate error because there is no equality sign. There is only assignment sign. So we are not assigning it, we are comparing it. So it should be equality sign. And 1 divided by 3 is equal to 0.333. It would generate false because although the values are very close, but they are not exactly equal. So either we can use less than or equal to sign, or we can use greater than or equal to sign to make it true. And if we will compare the string value, because it is in quotation marks, so it will be considered as an string value, not a number. So if we run this, there would be an error. So there are, please let us know if there is any improvement required in terms of lecture slides. Now, just to go very quickly about this. So we can use Boolean data type. We actually have been using Boolean data type if we are considering if and else if statements, because what these statements are doing is these statements are generating decisions based on true or false. And that's what the Boolean data type provides. It provides dichotomous values, which is true or false. And in Python, this data type is called Boolean variable. Okay, so there are two Boolean operators, and or, and they are used to combine multiple conditions, as I did in one of the example previously. So I combined two statements to make it more clear. So if we do not if we do not write the code in a chronological order, it would still run. So we can combine the conditions like this. So combining two conditions is often used in range checking, and both sides of the end must be true for the result to be true. So in this case, if the temperature is greater than 0 and the temperature is less than 100, so it should be between 0 and 99, then we can print the liquid. Even if it is 100, it will not meet the condition. And for the combined condition, we can also use or. Now, the difference between and or is that with and, both of the conditions should be met. It is important that both of the conditions should be met, then and only then the condition would execute the statement, the next statement. But if the in the end condition, one of the if with the end keyword one of the condition is false, then it would not execute the next statement. In the or one, it should be either this condition should be true or this condition should be true. In either of the conditions, it would execute the next statement. So this is the difference between and or. So in and, both of the conditions should be true. In or, only one of the conditions needs to be true. And there is not operator. So not is like kind of inversion, that if not attending or grade is less than 60, it should print drop. So either of the condition means if the student have not attempted the paper, and it should print drop, or if the grade is less than 60, it should print drop. So in both conditions, it should be dropped. And if attending and not grade less than 60, print stay. So the not is just like an inversion operator. So if it is true, it will generate false. If it is false, it will generate true. That's it. And there is inequality sign. We have already seen this. So if it can be used in multiple operations, but this is one of the example that if you are comparing the passwords, and if you want to see that if the password matches, then the next statement would be executed like you are authorized to access the file. And then you can use equality sign. But if you want to see that whether both of the passwords do not match, then you can use not equal to sign. And these are some of the Boolean operator examples that can be used for the coding purposes. And there can be common errors with Boolean conditions. So we need to understand that where we have to use and where we have to use or. So we have to think carefully while writing the code. And there is no golden rule to see or check or validate your code with respect to these conditions. You have to think carefully before programming. And you can follow the De Morgan's law. So De Morgan's law is basically designed for the Boolean algebra. If you have like studied maybe data structures or maybe something related to logical values, so you would know about the De Morgan's law. So De Morgan's law states that if not A and B is provided, it's the same as not A or not B. And if you are providing not A or B inside the parenthesis is the same as not A and not B. So they both are equivalent. So we can use these characteristics to write our code. And this is one of the examples to you can check this example and see that whether it works, the De Morgan's law works or not. I hope that it is clear. Let us move to analyze strings. And to implement analyze strings, what we need to do is we need to provide the assignment operator. And in this case, there is one more operator, which is in. So it checks whether this particular variable is included in the name or not. So in this case, if we have the name Paul Doyle, the expression DOI in name checks that whether this particular DOI is present in this particular name or not. And it will yield true because the substring, which is DOI, occurs with the string stored in the variable name. And we call this substring. We will see examples of this, that how it works. And the not in operator is the inverse on the in operator. So if you are using not in, it means that it will yield true if there is no expression like DOI is involved in this string. So it will yield if you will use DOI not in name, then it will yield false because it's already present in the ball DOI. So you can use different suffixes. So if let's say you are checking whether there is whether the string that is provided is an HTML file or not. So if you are checking, like let's say a directory, and in that directory there are names of the files, so you are reading those names of the files and you want to see that whether any of the file is an HTML file or not. So what you can do is you can use that particular file name and dot ends with, and you can write .html. So it would check that whether any of the file has an extension or that ends with .html. If it ends with .html, it will print that this is a HTML file. So you can use ends with. You can also use the starts with keyword to see what is the prefix of the file name. So these are some of the operations that you can perform, like substring in S. It returns true if the string S contains substring. S.count returns the number of non-overlapping occurrences. We will see that in one of the examples. And S.ends with will return true if there is like something that ends with the substring that is provided. You can return the lowest index in the string with the find one, and you can also use starts with to see if it starts with a certain value. And these are also some of the tests that you can perform. So you can practice and see if you can get the results as mentioned in this. So in this case, John equal to John will yield true. And if there is a smaller case J, then it will yield false. And some of the cases here are can be practiced in the code. And let me know if you have any queries in this case. But we'll see one of the example.
Okay.
So let's see that we have, let's say, web page equals to, okay, and we want to check that if web page dot starts with www. If the condition is met, we can print that this page uses www as their service. So this condition is met true. So it means that it's okay. So let us consider this. If web page dot ends with let's say .com, okay, and we want to print that this this web page uses .com suffix on its domain,
Okay.
and else print this web page uses other domain suffixes. And in this case, our web page uses .com, which is true. So let us see if we write here dublin.ie and we run this code. Of course, it uses www, but in this case, if we run this, it uses like this web page uses other domain suffixes other than .com. And if we want to find something, let's say if web page dot find equals to 1. So what it will do is it will print, um, let's say the domain is du Dublin domain, or else you can print out the domain is not du Dublin domain. So these are just examples. You can practice these examples and see that, or you can find the index as well. So let's say the web page dot find t, and it will return you the value that where this particular t exists in that string. So in this string, it's 0, 1, 2, 3, and 4. Okay, so it's at the fifth place, but in the index, because it starts with 0, it will return 4. So I hope these are clear. Um, so this is one of the things that we have to discuss today, which is loops. Now we have already understood the conditions, but we want to see that whether how we can iterate those conditions or how we can iterate some of the values. So let's say if you have a data set where we have 300 rows and we have to check the condition. So how we can automate that condition by iterating over those rows. So we need to run loops. This is one way to reiterate or get iterated to automate some of the execution statements. Okay.
Okay.
So this submodule will let you understand two types of loops in Python, which is while and for loop, and implementing the for loop and processing nesting loops. So of course you can use loop within the loops as we can do with the conditions. So if we can use nested conditions, we can also use nested loops. So the syntax for this is that so for the while loop, it considers let's say condition. If the condition is met, it would kind of end the loop, and it would try to run the loop unless and until that condition is met. So let's say if we have balance 10.0, the target is 100.0, the year is 0, and the rate is 2.5. And if we want to run the loop till the balance is less than the target.
Yeah.
So then what happens is it will kind of run the loop, which is year equals to year plus 1. So in this case, balance is less than target and the condition is true. While it is true, it will continue running the loop. And what we are doing here is we are adding the year, we are adding the interest, which is the interest rate 2.5 divided by 100 multiplied by the balance. So balance would be um, like 10.0 multiplied by 0.025, and then we will add the interest in the balance. So it would be something like 10.25 and then 10.5, and then it will try to run with the years because year is incrementing here. Once this balance is around 100, then this condition will not be satisfied and the loop will be broken. So this is how the while condition works. But for we need to provide that how many times the loop should run. So in while loop, it is based on the condition, but for for loop, we have to provide the condition that how many times the loop should run. So in this case, my string. So if my string has the value Paul, Paul, so it's like 0, 1, 2, 3. So if we write for letter in my string, it will run it for 4 times and it will just print the letter Paul. Okay. So the for loop can be used to iterate over the contents, and the container is an object that contains or stores a collection of elements, and it will just try to loop over that particular container. You can execute the statement in terms of storing it, or in terms of printing it, or in terms of any other execution statement that you would like to write. So this is a simple comparison. So let's say state name is Virginia, and we start from I equals to 0. That's initialization of the value. So while I is less than length state name. So the length here is 1, 2, 3, 4, 5, 6, 7, 8. So it will generate the length as 8, and it will run over the loop unless and until the I is equal to 8, because we are incrementing I here with every instance of the loop. So once the statement becomes false, then this loop will end. So that's the terminating condition. So we have to provide the terminating condition with the while loop. But for the for loop, what we can do is we can just write for letter in state name, print letter. So this letter doesn't needs to be initialized first. We are initializing here now because what we are doing is we are defining a variable which is in state name, and this will kind of like print till there is no letter that is remaining in this state. Or you can use range. So in this case, range will kind of like provide values, a number of values. So in this case, 1 to 10. So if the I becomes 10, until then it will print I. So it will print till 9 values. So remember that the range number that we provide at the end is we want to run the loop for less than 1. So 1, it's like the last digit minus 1. That is where our statement, where the loop for statement will end. Okay, and this is the same, but it's with the while loop, and this is for the for loop. So in while loops, we can use the Boolean values like while not done. So done is the false condition. So while not false, value is this, and if value is less than 0.0, then the done is changed to true, and once it is changed to true, this loop will terminate. Okay, and otherwise it will try to process the value as it is. Now, for loop example can be like this. So for I in range 6, so it will start from 0 instead of 1. So previously we defined 1 to 10. So it will start from 1. But if you will provide just one number, it will start from 0. And it will run till 5. So 6 minus 1 equals to 5. And if you will define it like this, 10 to 16, of course, you are defining the first number. So it will start from 10 and it will end to 16 minus 1, which is 15. And for I in range 0 to 9, and then you define a step value, which is 2. So it starts from 0. It ends at 9 minus 1, which is 8, but it will be with the step value 2. So after 0, there will not be any 1. There will be 2. Then there will be 4, and then there will be 6. So the step size will be up 2. And for I in range 5 to 0, so in this case, it will start from 5. And the step size will be minus 1. So it will be 0 plus 1 in this case, where it gets terminated. So this is how you can implement the for loops. I hope that you can answer this question after going through these slides. Now, of course, complex problems require nested loop, and there are many examples of this. But we will discuss some of the examples. Now, one example I can give you is that if you are dealing with images. So in images, there are rows and columns. So if you want to iterate over each pixel value, you need to first consider the rows from left to right, and then columns from top to bottom. So this is how you process the data from left to right, top to bottom. So you have to use two nested loops. For row, it should be first row, and then it should consider columns. So in this case, you need to use two loops. Okay, and that are nested loops. So there is one inner loop and the outer loop. So the outer loops iterates over all the rows, and the inner loop iterates over all the columns. And this is true for the tables as well. Now, if you have a data set, which is a structured data set, then there will be rows and columns. And what you want to do is you want to iterate over rows and columns. So the outer loop will iterate over all the rows, and the inner loop will iterate over all the columns. And this is one of the example. So let's consider an example where we want to print a table header that contains x to the power of 1 and the power of 2 and the power of 3 and the power of 4. And we want to print a table contents with 4 columns and 10 rows that contain the powers of x and where x is equal to 1 to 10. So we'll see this example in the code as well. So in this case, we have 10 rows, and these are the values of x's that needs to be printed in a table structure. So we want to print the table header, and we want to iterate through the rows. So what we want to do is this is a pseudo code. So for x from 1 to 10. So again, it would be from 1 to 10 rows. We want to print a new table row, and we want to print a new line. And for each column from n1 to 4, we want to print the value of x power n. In this case, here we want to have 4 columns and 10 rows. So here it is.
Sundar, just quick.
Yeah.
Sundar, a quick question. Do you always do the row first and then the column, or do you ever do the column first and then the row? What's the
It
convention?
depends that how you want to. So in this case, what we are doing is the outer loop first runs of the outer loop was first considers one row, and then
Mm.
it processes all the columns, and the second row, and then processes all the columns. So if your application, or if the code, your code or your example requires that you should keep the first row and then process all the columns, then you can do the same. You can use the outer loop for the columns and the inner loop for the rows. So it depends on what you want to do with the data.
Okay.
Okay. I hope that you can answer this after going through. So let's go with the example that we have been dealing with. One more thing is that we need to understand if we include and here in the print command. So it would not print to the new line. It would continue printing to the same line. So in this case, if you will see, we want to print in the same line for all the columns that we are executing. And for the rows, we are printing it to a new line. So we want to only move towards new line once we have performed all the operations on the column side. So what we can do is we can use AND command to make sure that it should not be printed on the new line. Rather, it should be continued printing on the same line to give it as a table structure. So what we want to do is we want to see for X in range 1 to 11, because there are 10 rows. So we will add 11 and it will run the loop with to 11 minus 1, which is 10. And for N in range 1 to 5, because there are 4 columns, we would add here 5. And what we do is we print. So this is the %5 is like the number would be up till 5. So 5 numbers are allowed, 5 digits are allowed. And the value that needs to be printed is X power N. So if it is X is 1 and N is 1, so 1 power 1. If X is 1, N is 2, so 1 power 2, 1 power 3, and so on. And we would use AND so that this operation in a particular column should be printed out in the same row rather than printing out in a new line. And then we use print command to print a new line. So that is how we maintain the table structure in this case. Okay. Uh, okay, so let's just, I think, use this code to see whether it works or not. So let's say for X in range 1 to 11 and for N in range 1 to 5, what we want to do is we want to this print this statement. Let's just so in here we would add one space so that there should be some spacing, and then we will use print. Let's see what happens. So you will see that the table same table that we are using is printed here. Okay.
Yeah.
And then uh, of course, you can use for loop for iterating over the contents of any container and all that. So I hope that you can answer these questions now. And of course, you can process strings with the loops. So let's just go them very quickly. So we want to process and evaluate strings using while and for loops, and how we can do that. We can use counting matches, we can use finding matches, or we can validate a string, we can build a new string. It depends on us that what type of code or what type of example we are dealing with. So let's say if we want to count the matches, so for each character in the string that we have defined, we will count what are the uppercase letters. So in this case, if you let's say, let's see with the example. So if we have the string which is called dog, okay? And what we want to do is we are initializing uppercase equals to 0, which is currently 0, and we want to loop for character in string. So for character in string that we have already defined, we want to see if the character is the uppercase or the lowercase. Okay. So if the character is okay, uppercase is uppercase, and we can see what uppercase is. So there are two. So it means that there are two uppercase letters. So we can use these string operation in this case.
Very good.
And then we can use it for vowels, we can use it for lower cases, we can use it for other operations as well. And we can also use it for finding all the matches. We have seen that we can find the matches in this case. So we can find all the matches. Let's say I can give you one example of finding. So let's say we have new string equals to Ellie Ellison. And we want to find that, let's say we define that the substring is Ellie. Okay? And we want to find that new string. So if substring in new string print the substring exists in new string. So in this case, the substring exists in new string, and because Ellie is existing in here. And what we can do is we can count it. So if we want to, so in this case, what it is doing here previously is uh, uh, it's let me example. So previously we had an example of counting. Okay. So in here there was, so you can check the methods, that which methods are used for counting. Uh, okay, so I think here it will be for counting. There will be a yeah, yeah. So you can use this s dot count substring. So in that case, if you will write new string dot count substring, it will provide you two. So it means that LE exists at two places. Okay. So just resume. So you can use all of these operations for counting, for making that whether there is an uppercase letter or whether there is a lowercase letter and you want to print it. So you can perform all these operations with the loop. And this is the while loop, which kind of like analyzes the position with respect to the length string. So if the length string is like none of the strings are left in that particular string value, then it will terminate the condition, the loop, which is while loop. Otherwise, it would try to iterate over again and again. Okay, so this is one of the examples for finding first match. And this is the example for finding the last match, that whether this match is in there, the last match. And it can be used for multiple operations like this. So you can use it whether that we use it for the like identifying whether the card is Visa type or MasterCard. So this can be used for such applications. And if you want to build a new string, you can use read the card number, initialize the new string to the empty string, test each character in the user, and if the character is not a space or dash, we append it to the new. So this is how you create a credit card number. And again, for as a programming tip, you can either use while loop or you can either use for loop. So please let me know if you have any questions regarding this.
Okay.
But I think it's a lot clear from the examples. But again, if there are any questions related to this, please let me know.
All right.
Or you can post it in our like the group,
Okay.
so we can discuss it over there as well. Or you can message me.
All right.
So I hope the loops and the conditions are clear now, and I hope that you are able to use these loops and conditions in your own code.
Okay.
Okay, so if there are no questions, we can end the session now, and we can see each other next week.
Okay, thank you very much for that, Sundar. That was very helpful. I see there's a Jupyter Notebook at the end of the session to be submitted for next week. So I'll have
Yeah.
to submit that by Friday. Okay, that's for grand. And a lot there today, with a lot to go through, but I mean, I'll go through it very carefully and I'll come back with any questions to yourself or to the group.
Okay, and I'll share this video. Hopefully the video will be available by tomorrow. So you
Good.
can watch this video, and I will share the link in the meeting chat as well.
Excellent. That's very good. Thank you very much for that.
See you then next week. Bye bye.